Okay, so here's the problem. Set up an integral with respect to the y variable for the surface area. And the surface is generated by this function rotated about x-axis. Step 1, you have the graph. Okay. The graph x is between 0 and 9. So that means when x equals 0, y value is 1. When x equals 9, the y value, should I change? Yeah, 9, it doesn't matter really. Okay, we set up an integral. So this is here, right? It's 9. Okay, so the curve is, it's part of a parabola actually. Do you know why, right? It's a y equals square or something. It's part of a parabola. So rotate about x-axis. That's a picture. So that's the first picture. Okay. Next, you have to pick up an arbitrary point on the curve, original curve, and then draw the radius. Tell me, what is R, right? R is going to be the y value. Okay. Now, I'm asking to express the integral with respect to y variable, not with the x variable. Okay, so that means the surface area should be some integral with respect to y variable, right? So, yeah, otherwise you cannot get full credit. Right? So let me write down the initial integral. It's a 2 pi r ds. Okay, if this is arc length, it's s is the arc length of the curve. Okay, but you cannot use that one to evaluate integral unless you know, unless you can express the radius in terms of s, unless you know L, the length of the curve already, the two things. So it's important. So you have to change the variables. It sounds like a substitution here. Okay, so we know I equals y. We have to express s ds in terms of dy because we are asking for dy. Okay, so that means so it's going to be dx over dy squared plus 1. So you have to use that formula. Okay, now what is the range for the y variable? If x is between 0 and 9, that implies y is between 1 and the square root of 10. Right? Square root of 10, because when x equals 9, y equals 10. All right, so that's the domain. Then you can change the variable s to the variable y. It's a substitution. So it's 1 from square root of 10, 2 pi, r is y, so don't need to make any change. You don't need to put f of x. And and the derivative of x with respect to y. How can I find x? Because y squared equals 1 plus x. X is going to be y squared minus 1. So that will be the derivative of x with respect to y. It's 2y. Okay, that you can evaluate this integral with any problem. Okay. Yeah, you have to begin with the original formula and have draw the graph. And yeah, if I ask you to use the variable x, if I ask you set up integral with respect to x variable for the same surface with respect to the x variable, how can you do that? Well, you still have the same formula, but this time you have to say, I still y, not change yet. ds, you can change it to dy over dx squared dx because you're using x variable. Then you say, oh, y is not expressing, but y depends on x. So x squared or x plus 1. Then the integral is 2 pi r ds, right? Let me write this again. Change it to the variable x. X is from 0 to 9, 2 pi, and what is r? I is square x plus 1. Then plus the derivative y with respect to x will be this. It's more complicated, right? But still can be evaluated. All right, so this is another thing. You don't need to waste time to evaluate this integral. I'm going to ask you to do the problem Again, but this time the surface still y equals square 1 plus x, but x is between 0 and, let me put the 8 here, okay? Make it easier to, I don't want to square 10. Okay? The rotation is about the y-axis, okay? So I'm going to ask you to set up integral with respect for the area with respect to x variable. For the area, the integral must be with respect to x variable. All right, please do it. Again, draw the picture first. You have to draw the picture. Don't just put it in the formula. No formula you can use. Okay, it will be changed. Depends on the graph. So only formula you can use is this integral, okay? It's a universal formula, okay? Then you have to determine what is R, what is A, ds. ds is easy to figure it out, just square root of, right? You know, there's only two forms there. You can use x variable, you can y variable. But we're asking for x variable, so ds is clearly should be used this form, right? It's integral with respect to x. Okay, so R could be, you know, and then you have to look at the picture. This is oh sorry, this is the curve is above the axis. Yeah. So this is a curve, right? And the rotate is about the y variable. That's the picture. About the y-axis, okay? And the y-axis. So this is the picture. And then this is original curve. This is original curve. You pick up an arbitrary point x and y, right? And you draw the radius. You have to draw the radius. This is radius. So the radius is going to be the x. The radius is the distance between those 2 points, right? This is x, this is 0, x. So clearly the radius is going to be x. And you let the point P, let the point moving around the curve. So x, but this is our integral is with respect to x. So you don't need to do anything. Now, if you put f of x, it's wrong. Okay, completely wrong. Okay, so it's already expressed in terms. So area is going to be integral from 0 to a 2 pi x 1 plus dy over derivative. It's still yeah, dy over dx is still the derivative of the function. Yeah, so that's it. Now, if I put the same problem on the test, some students, one set of students probably put square root of 1 plus x in the place of x. Okay, without understanding why I have to put that. Okay, because that's the radius, but radius is not a f of x here. Okay, this is a rotation about y. Okay. Okay, so this is a radius. That's the ds cut. why that formula 2 pi RDS is correct, but this formula was derived by you see, if you have a cone, right? A piece of cone like here. If this part is, let's call it ds, right? And then in the middle that's ds. Then by direct computation, the area is going to be 2 pi RDS, that piece. Okay, you can do the calculation. So if you have a surface, something like that, right? Doesn't matter where's the axis. Could be horizontal, could be vertical, could be any position, right? This is your original curve. Your original curve. And then from here to here is S. Then you take ds, a small piece, then you cut it. Okay? And this is radius. And that part is almost equal to pi ds. Then integrate it, just add them together. That's a rough idea. You know, we don't use a Riemann sum to give you a formula because we skip that part. But that's the way, how do we set up integral? This is a rough idea. Yeah, take a small slice. You cut the whole surface into many slices. Take each slice, and you take a small slice. Then you can express the area using this formula 2 pi RDS. Okay, then add them together. The total area is going to be the integral 2 pi RDS from 0 to. Okay, that is our formula. Okay. Then you can use that formula to evaluate the surface area. All right. So I have a test 1, version 2, and 3 here. So do you have any questions about the problem? Any of them? So I can discuss in the class. I will not post the solutions to those sample tests. Yes.
Can we talk about number 5 on sample test 1B3?
B3, okay. Number 5, B3. Good question. Okay, the half-life of radioactive material is so we know that the half-life T is going to be 900 years. Okay, and when the mass be reduced to 12.5% of the original. Okay, that's the question. Now there is a shortcut. I'm surprised because this is a problem I put on the previous test, and this is a shortcut I don't want. Okay, you can assume 10% or 5%. Okay, you should be able to do this type of instead of 12.5% is like half-life, 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 right? How many times? So half-life 50%, another half-life 25%, then half-life. You see, that's a shortcut. But I did not know that student will use that method. That's, yeah, you shouldn't use that. Let's do the little bit general. Okay, when will the mass be reduced to, let's say, 5%? Okay, I'm not going to use it. So this is a method I wanted to know, original quantity. Okay, doesn't matter 25% or 5%. All right, step 1. Okay, I forgot the half-life formula. So first of all, you write down the formula for the, you can use a Q, you can use a P is population, right? And that is a P over T is going to be P0 e to the KT, okay? That's, write down that formula first. Okay, decreasing means K is negative, okay? Half-life means when T equals 900, right? When P equals 900, okay? This is going to be half of the original quantity, okay? That's called half-life because P of 0 is going to be 0, right? That's the initial value. So then use that will be half of P0 equals e to the 900 k, because when t equals, so initial value does not play any important role here. All right, so my first identity for the half-life, because I couldn't memorize this at all. So this is the definition of half-life, okay? So that determines the value of k. How can you see that? You can say put natural log 1/2 equals 900k, okay? So you already get the k, value of k. You can, the k is going to be 1 over 900, natural log 1/2 half. Now this is a negative value, okay? It's negative, the reason is going to be negative. This is a negative number, okay? So you get the exact value, don't need to estimate. If you give me some strange number there, decimal points, and so did I forget to watch? You're not using calculator, right? How could you find out these numbers? Okay, I will come to check. You cannot say you have super memory, okay? Okay, so that's it. So what do we want to do? We want to find the time such that the quantity is going to be 55% of the original, okay? So that means find the time t such that p of t is going to be 0.05 original time, right? That's original. Yeah, 5% of the original. Okay, so that means p naught e to the kt. Okay. So again, the initial quantity does not play any important role here. So now how that can, I already know the k, so yeah, don't use it. We will use a k later. Okay, so you put the natural log on both sides. K equals natural log 0.05. If for the original, if 12.5, just put 0.125. Okay, then the t is going to be this number, right? We find the time t, but I already know the k, so let's put the k. The k is here, right? So what you should do, it's going to be natural log 0.05, natural log of 2 over 900, negative sign. Then you turn upside down. You get natural log of 0.05, natural log of 2 times 900. Okay, and there is a negative sign here. Can we simplify a little bit? It's possible because 0.05 is a number we don't like it, right? So 0.05 is 5 over 100. So what we can do, right? We can modify a little bit, okay? 5 over 100, right? If I have a negative sign, then turn this upside down. So we can change it to natural log 100 divided by 5 is going to be 20. Yeah. Okay, that looks better. Okay, 20 is 2 times 10, but we still cannot handle natural log of 10. So that should be the exact value of the number. Okay, it's larger than, of course, it's larger than 900. Much larger. Now you can do estimate. 2 to the 4th, it's 4 times 900, more than 4 times, less than 5 times. Okay, so this number, okay, this number is greater than 4, less than 5. Yes.
ln over ln, maybe ln's cancel out.
How? Which formula are you using? No, we don't have such a formula you can cancel out. ln is just a, you see, ln a is a name. Ln is just the name of the function. It's actually the ln a parenthesis a, right? So this is just a name. This ln itself is not a number. You cannot cancel it. It's not a number. It's not like a ln times a. Okay, so natural log of a really means the value of a, the value of natural log, right, of a, yeah. Okay, so you cannot cancel out. Okay, just like a square of a over square of b. You cannot say it's going to be A or B. You cannot cancel. This is just symbol. Okay, there's no such, but it's going to be square root of A or B. That's possible, but this still there. Okay, yeah. Okay. So here, natural log way, it's another function. It's not radical function. The natural log of 20, if it's like a natural log of 16, you can cancel natural log not because they have, but it's not like a direct cancellation. It's going to be natural log of 2 to the 4th power. Okay, we have the formula, it's 4 natural log of 2. Okay, then these two numbers can be canceled out. Right, not that because natural log. Okay, because these two identical numbers, natural log of 2, natural log of 2, those are two specific numbers. Two numbers, this can be canceled. Okay. Yeah. So to solve this type of problems, step 1, you determine the value K. Okay, using the half-life. Half-life determines the value K. Then don't be in a hurry. Just you keep it here. Then you try to find the time t. I usually, when I was grading the test, I usually want to see this one. If I don't see this identity, that means you don't understand what it means to 5% of the original. Yeah, that's a key step. Okay, the rest of them just trying to solve it. Okay, we pay more attention to the key questions you posted. So you have to show the details as much as possible, and there's no need to circle the answer somewhere at the corner of the page, because you should learn how to express it clearly in the very organized way. Okay, then I know the answer where it is. There's no need to circle it. Okay, this is a habit someone built up in the elementary school, always circle the answer somewhere. Because in elementary school, the teachers only check the answers. They don't check the steps most of the time. Yeah, do you remember, right? Sometimes you don't need to turn your homework. Right? But here we have to see your ideas clearly, step by step. Right?
Can you go back to the top of?
Yeah, write down this first. If we are using this formula, write down the formula first. Don't jump to some middle steps. Okay? Okay. It's not like, oh, you're trying to find an answer. Remember, forget this idea. Not trying to present the ideas to solve the problem. Just write like a report. Don't jump to the conclusion. You have to give the reasons. Okay? And organize it as much as possible under the time pressure. Okay? Yeah, you have to say, here's the formula I'm going to use, put on the very top. Then if you already know the formula, how to, what's the relation between K and half-life, you just write down that. It's okay. But if you don't remember the formula between the half-life and the K, then you have to derive it by yourself. Okay? So otherwise you can short, the steps. Then you have to say, I'm going to find a time t such that P of t equals 0.05 P. That's it. Then you solve it. Okay. Question? Any question?
Version 2, number 5.
It's also number 5. It's integral, right? Now, when you see 1 plus x squared inside the radical, you probably link to the trig substitution. Maybe it works, but not the best choice. Why? Because this is a very special integral. Even I can give to you before you learn trigonometric substitution. Okay, why? Because there's x on the top. That makes the integral very simple. So you have to let u to be 1 plus x, then du equals 2x dx. Okay, so the integral becomes a square of u, and the x dx is half of the u. Right, this is just integral of the power function. Right, integral of the power function. Okay, then that will be, I think just the antiderivative is just u to the 1/2. Okay, when you differentiate, you get half of. Right. So that is going to be a square 1 plus x squared plus c. Okay. Yes.
So just we don't use trig sub because it has the x on the numerator.
Well, if there is other substitutions, you can use it. Then use other substitution. It's much simpler. Okay, in this particular case. Okay, you can use substitutions. That just takes more time. Yeah, trigonometric substitution.
If the integral was 1 over root 1 plus x squared,
then you have no choice. Yeah.
Okay.
You have to use a trigonometric substitution. But this way you can, right? 1 plus x squared, right? You have to use a tangent theta, right? That's okay, yeah. Use tangent theta, then 1 plus x squared equals tangent square theta plus 1, which is secant square theta. Okay? So then you have to see what is dx. dx is tangent theta, secant theta, d theta. You see, you have to memorize lots of stuff here for this part. Yeah. Then the integral becomes x tangent theta dx tangent theta secant theta d theta. Okay. Then the denominator is going to be square root 1 plus its actual secant theta. Okay. So secant theta cancelled out. You will get tangent square theta d theta. Okay. Now, question: how do you evaluate this? Okay, how do you evaluate this? But tangent square theta, okay, is related. I know the derivative of tangent, not tangent theta. Wait a minute. The derivative of, maybe I made a mistake. The derivative of tangent theta is a secant square theta. That's right. Don't yeah, confused. Yeah. So yeah. So the derivative secant square theta, right? Yeah. So secant square theta. Yeah. You see, it's easy to. Yeah, because it's a sine theta over cosine theta. When you differentiate, you will get 1 over cosine square theta, which is secant square theta. Okay. So that's it. Okay. So after you cancel this, you get tangent theta, secant theta, d theta. Now that is already known as the derivative of secant theta. So it's a secant theta plus c. Then you have to change it back. Okay. When you change it back, this is given square root 1 plus tangent square theta plus c, which is 1 plus x squared plus c. You see that you have to go through all the substitutions. It works. Okay. So some integrals I put there, you have multiple ways to do. Okay. You have two options. If you realize that I can use a very simple substitution, you can quickly solve the problem. Okay, and remember, list a very few important methods you have to know, like the trigonometric substitution, like the integration by parts, right? All the things. So ask yourself at the end, have I used the integration by parts? Not yet. Something, so I have to go back. Okay, there's some problem. You have to use this integration by parts. Okay, yeah. Right, any other questions?
We do, test one, version two, number one.
Version 2, number 1, okay. So we're given the function 1 plus 2x plus sine x, okay? We want to find the derivative of this, okay? We are not able to find the general formula for the inverse function in this particular case, okay? But we know the function has an inverse. You know why? Okay, here's a we don't need to prove, but I guarantee you. Okay, so it's the inverse exists just because the derivative of the function is going to be 2 plus cosine x. But this is always greater than or equal to 2 minus 1, which is 1. 1 is positive, right? So the function is increasing. Okay, the function is increasing, and yeah, so the function is increasing. That means the inverse exists. Okay, the inverse exists. Okay, so don't worry about that. But we want to find the the derivative of the inverse at 1. First of all, we don't know how to express the inverse function in general, but I can at least figure out this value, which is going to be 0, okay? Because f of 0 equals 1 plus 2 times 0 plus sine 0 equals 1. So the inverse exists, that's why 0 is going to be there. Yeah, it's this part you have to guess, okay? You guess and try, okay? I know the value, but I cannot get the general formula for the inverse function using elementary functions. I know it exists. That's all enough. Then you have to use the formula. You have to use this formula to evaluate the derivative, find the value of the derivative. But I already know that the value of the inverse at the 1 is going to be 0. So all you have to do is just evaluate the derivative at 0, the derivative of the original function. Original function is already 2 plus cosine 0, so it's going to be 1/3. Okay? Any attempt to find the inverse function first will fail. Okay? Unless you use some strange algebra by mistake, then you get the solution. Okay? So the formula we give to you, you're not able to find the inverse. If you find the inverse, then you definitely use a wrong algebraic formulas. You only show up your weakness of the algebra to me. Okay, if you want to solve it. I really wish you have done all the problems without any troubles, okay? If you haven't done those remaining two tests, you're behind the schedule a little bit. It's not much time left because today or tomorrow you just finish those 2 tests is not enough, because when you finish those 2 tests, you will know where is the weakness. So you have to go back to the corresponding section and do extra problems. Okay, that's the way how do we prepare for the test. Okay. Any other question? If you don't have a question, I'll ask you one more question. Okay. You are given the function natural log, right? Square root of 1 plus cosine x. Right? Find the derivative. All right. The best way to solve this problem is not to use quotient rule. Okay. I have to use chain rule, of course, right? The radical. How do you deal with radical? You have to take the radical out. Okay, that's the best way to do. Okay. Then just apply the chain rule. You differentiate. Okay. So dy over dx is in 1/2. It's inside the natural log, so this term should be go to the denominator. But you have to differentiate 1 plus cosine x. So which way is going to be given negative sine x? That's it. So the answer will be sine x here on the top. So if you know how to do this problem, it takes only a few seconds. Write down the answer. Okay? Yeah. If you're trying to use a quotient with a chain rule to differentiate square root of 1 plus x, 1 plus cosine x, then it takes much time. So another problem, similar. Okay, x squared over 1 plus x. Find the derivative. Okay, this is a little bit more difficult than the above one. Okay. I hope you can do it. No. So you may not able to solve other problems, but you should be able to find the derivatives, right? Yeah, don't lose points on the derivatives. Yeah, okay. In most of cases, the derivatives just applying the formula directly. But this one a little bit tricky, small tricky here in how to simplify the computation. Okay, you can always get an answer than that, right? But there's a little bit easy way to find the derivative. All right, so this is already gives a hint, right? You have to get rid of radical first, simplify the computation. But this is not enough because when you see inside it's a fraction. So if you differentiate, use a chain rule directly right now, you have to use a quotient rule to find the derivative of the inside function, right? But that also takes too much time and it's easy to make mistakes. So the best way to do is to use the property of natural log. Okay. Then even that, natural log of x can become just x. So you can write just 2 natural log of x. Okay. Then we are ready to differentiate after we modify this function. So the derivative is half of 2. The derivative of natural log of x is going to be, you can put the absolute value here, doesn't matter. When you differentiate, you get 1 over x. Okay? And the second one is just 1 over x plus 1. That's it. Done. Okay? So you can, if you leave like that, I'm okay, I'll give you 4 credits. You don't need to combine into one single fractions. Okay? But if you want to do it, you can do that. Okay? You can continue x times x plus 1, and that's 2x, 2x plus 1 minus x will be just x plus 2. Okay? So that's fine.
Did you get rid of the 1/2 and turn it into a 2?
1/2. Oh yeah, you're right. It's 1/2. I don't know. So that's what I did. I couldn't get 100%. Okay, I never got 100 points on my calculus test. I'm not lying to you. I always lose 1 or 2 points somewhere here. Okay. So just like the SAT score, some students say I'm perfect, I'm great in math, but still impossible to get 800 points, right? Total. Yeah, so it's the gap between 96% and 100%. That gap not depends on when it closes up. Does not depend on your knowledge in math. Okay, it's like a personality kind of things. Some people can cool down and concentrate and doing the problem and get 100%. Okay. All right. So I expect there's one student get 100% on this test. Or maybe 2. I hope so. Yeah. So that's it for any other questions. If you don't have, I'm going to give you a quiz.